Welcome back to Detailed, an original podcast by RCAT. This is a show where we uncover lessons learned to help you navigate your next project. I'm Cherise Lakeside, Senior Spec Writer at RDH Building Science, and your host. My guest today is Ken Faulkner, Associate Principal at Adjaye Associates in their Accra, Ghana office. In addition to the Accra office, Adjaye also has offices in New York and London. Ken is an associate principal at Adjaye Associates, where he currently oversees projects throughout Africa after initially joining the London studio. With over 30 years of experience in designing and delivering complex international projects, Ken previously served as a director at both Kohn Pedersen Fox and Foster & Partners. Ken is an expert on rammed earth construction and has worked on some of the most innovative uses of the technique around the world, including the King Salman Park Visitor Center in Riyadh, the Barbados National Heritage District, and the Museum of West African Art, MOWAA, in Benin City, Nigeria. The project we are talking about today is the Museum of West African Art Studio, MOWAA, in Nigeria. Tucked within the historic moats of Benin City, Nigeria, the Museum of West African Art Institute, MOWAA, emerges as a contemporary landmark deeply grounded in tradition. Built from rammed earth and other locally sourced materials, this low-lying, thoughtfully designed structure marks the first chapter of MOWAA's ambitious creative campus. It stands as both a pioneering example of sustainable architecture and a tribute to the cultural legacy of the Benin Kingdom. Now, let's get into the details. Welcome back to Detailed. My guest today, I'm not going to lie, I'm super excited. My guest today is Ken Faulkner, and I'm going to make him laugh as I try not to butcher all the words I just learned how to pronounce. Associate Principal at Adjaye Associates in their Accra office, Accra, Ghana, in case you don't know where that is. I had to look. Adjaye also has offices in New York and London. The project we are going to chat about today is the Museum of West African Art, or MOWAA, Institute in Nigeria, a place I've also never been. Ken, I'm thrilled to have you here today. How are you?
I'm very good, Cherise. It's really good to be here.
Well, it's an honor to get to talk about this project. I don't think I have been as invested in writing questions and as curious about maybe any project of the 130 interviews I think I've done on this podcast, and I have been about this one. So you're stuck with me for a while because I have a lot of questions.
Okay, no pressure then.
Oh, no pressure at all. So I start every episode with a little icebreaker question to warm us up, get to know you a little bit. So I did a little trolling on the internet of you beyond the bio information you sent me, and a little background research, and found that you were born in Detroit, Michigan, received your architecture education at the University of Michigan for your bachelor's degree and Harvard for your master's. Impressive. From what I could gather, you then went to work in London, and now you're in Ghana, but you've done projects all over the place. So I'm curious, what made you decide to go from Detroit and venture off to London to become this international architect at a very well-known, well-respected firm?
Wow. And you make it sound like this great journey, but this is just what happened to me. So I actually just, my architectural education actually started before University of Michigan. I went to a small commuter school outside Detroit called Lawrence Technological University, where I started architecture. And I was working in a local practice at the same time. And I transferred to University of Michigan, but before actually getting to Michigan, I decided that I wanted to do something to distinguish myself from the other students who'd already done the same thing. So I actually did a junior year abroad sort of study program that I made up myself because it didn't really exist for architects. And so, and I ended up at the Bartlett School in London, which is one of the two main schools. Aside from the Architectural Association, the other one that people talk about a lot is the Bartlett School. And so I was there in 1989, and I have to admit, it changed my life. The two things that were key in all of it were basically the way that the architecture studios were taught, and in the US, in my experience at the time, studio was separate from, learning about structure and services. Whereas at the time, at the Bartlett, it was all integrated. So you had your studio project, and then you had tutors come in to help you with your studio project to talk about studios services and structure. And they actually had engineers from some of the consultancies, the well-known consultancies giving us tutorials. So that made me think about architecture in a very different way. And then, of course, when I was there, I was able to travel in Europe to France, Italy, Switzerland, and start to see all of these modern buildings in contexts alongside the historical buildings. So those are the things that made me want to return to London after I finished my master's, so that I could really learn about this approach. And I'm still learning.
And you're still not in the United States. I, I
Yeah.
I love to travel, so just the countries, especially in Europe, are all so close together. There's just it's so rich and it's so old, and there's so much.
Yeah.
Um,
I'll tell you just a little something. When I first went to London, being from Detroit, Detroit is a very regular city, grid city. Streets go on for miles, so you can always work out where you are. You can't really get lost. And I had a real problem when I first went to London because the street names change when you cross the street, and then they curve. And so I was that really annoying tourist with a map that I unfolded before I knew that you could actually get the small sort of pocket A to Z to actually get around. So yeah, I did learn a few things.
I would be in trouble because I have zero sense of direction. I joke that I get lost going to the restroom. Um, so let's talk about this project. And I as I was going through all of the information, I was just like, I don't even know where to start. So how about, because this is such a foreign concept to almost everybody in our industry, why don't we start with you telling me exactly what is a rammed earth project?
Okay, so I'll just try and define rammed earth, just very, very simply. Rammed earth is actually a dry mix of sand, gravel, and clay. And um, realistically, they're in a form about 400, 450 mil thick, so 18 inches wide, and they're installed. It's installed in layers up to say 2 feet, 600 millimeters, and the layers are compacted by either by hand or pneumatically, and then the form can be lifted up, and you can continue the process with the pressure of the ramming. You actually can build up your wall. So unlike concrete, even though the elements are similar, you don't have to cure it, but it's the ramming that actually gives you the solidity within the walls. And so you can move the form, almost right after you do your ramming, to keep going up, on a continuous basis as you're building the wall.
I'm going, usually it takes me a long time to go down a rabbit hole question, but I have to ask, did the forms stay in place? Do the
Um, so it's
forms come
interesting.
off?
The forms come off. The forms. It's okay. So we're not talking large forms like your 4x8 plywood forms for concrete that you're then pouring the mix in. These, because the layers are only say 2 feet. the length or height of that form is only about 2.5, 3 feet. And so it's almost it's portable. So you have your tie rods that go through normally, right? And then when you finish that layer, you can actually take the form off and install it higher, and you put your tie rods back in, for the upper layers. And you can just keep going because the thing is, as I said, it's the compaction that gives the wall its solidity. So when you take the form off, the wall stays in place. It doesn't it doesn't fall out of the floor. And actually, because the mix is still a bit wet, you can fix the holes then and there. So you never see the holes either. That's the other beauty of it, is that you can't actually see the evidence of the ties the way you would in concrete.
So what is in the, because all I'm thinking about is you take off those forms and then it rains and the whole building melts. That's what's going through my head right now. What's in the mix that
So
keeps it together?
it's actually the clay. The clay is the binder, right? Because and the mix with the aggregate and the clay, normally that's what it takes to bind it. So pure rammed earth is only those elements. And you're right, one of the concerns that many people have is erosion and what happens to the building in the rain. Now, there are different ways of getting over this. Um, you know, Many times the pure rammed earth consultants will say that you need large roof overhangs so that the rain doesn't get to them. There are also erosion breaks that you can install so that when the rain actually hits, say, the wall or a corner of the wall, an erosion break, it was just a bit of, say, stone or clay that's just horizontally within it at probably at just the layered distances, 600 millimeters. And that stops the erosion from happening because each one is then an overhang. So then, if you don't have the overhang, the whole of the wall then gets hit with the rain and it can wash away. But because you have the breaks, it only does that on a smaller part. And and the other thing is the rammed earth is actually completely rebuildable, recyclable. So you can touch it up with a clay plaster after that happens. You can maintain it very easily if you know what the mix was.
So this isn't a construction type that most architects have any exposure to, or even sometimes a chance to even see a project like this. How did you learn? How did I mean, because it sounds like you're probably kind of considered an expert in this field. I've seen your projects that are, and they're pretty incredible. How did you even learn to do this? How did you end up designing rammed earth projects?
So okay, so the use of rammed earth comes, of course, from our founder, Sir David Adjaye, right? David, on one of the previous projects, one of the ideas of how these buildings were meant to be formed is that they were meant to be coming out of the earth, right? Because we do our projects are firmly rooted in our context. So, you know, I mean, what better way of expressing them coming out of the earth is by you actually using the earth to construct your buildings. You could use stone, local stone, but then, of course, from a sustainability standpoint, um, that's not the lowest carbon option. But the rammed earth was something that we thought would be a very good way of expressing it, dealing with sustainability, and yes, doing many things. And here in Africa, there is a tradition, of course, of mud building, earth building. And so what we were interested in trying to develop an African architecture here on the continent. What better way of doing it by using the earth from your context, which is why all of the buildings look a bit different. The colors are a bit different because the soil that's available is a bit different. And I've mentioned pure rammed earth, but I guess it should be said that on some projects we've used cement actually in the mix, because if if there is a concern from a client about things like erosion. Of course, the cement is a way of making it more permanent. But the difference between the cement content of concrete, which is about 30%, um, and rammed earth, is when you have it as cement stabilized, it's down to about 8%. And then with pure rammed earth, there's no cement. So we're about this sort of range that we can work with. And we also have put in, because we're trying to develop, use traditional materials in a modern way. So the addition of cement, sometimes the addition of um, waterproofing admixtures, so we don't have to do any cladding to it on the outside or inside, and we can actually have that finish, the one material as the finish on the outside and the inside, is something that we are really interested in, and we are going to continue to explore.
What would you say are some of the biggest benefits of this type of construction?
The benefits, I think I've touched on some of them there. I think the low carbon aspect, definitely one. You know, and one of the things that we are very interested in, of course, is truth in materials. And so the approach of having, say, all of these different elements, normally in the West, we're looking at structure, we're looking at insulation, we're looking at vapor barrier, we're looking at cladding, you know, and glass, all of these things that then make up, and then you're also looking at what is your finish on the inside. So then you've got some sort of stud system, whether it's metal or timber and plasterboard. You've got all of those things, that whole sandwich that then makes up your wall. We've got something that is your wall, and that's your finish on the outside and the inside all at once. So the interesting thing in the construction of the MOWAA project is, while it seemed to take a while for the concrete and um, take longer for the concrete and rammed earth to actually enclose the building, but once we did that, we were done. So there is that aspect to it. I'm actually going to go back because you did ask the question about where did I learn to do this. Now, I guess it's from a lot of research that the office has done, number one, and then doing these projects. There are a couple of contractors here in Ghana who specialize in earth construction. We worked with one of them on one of our previous projects called Sandbox, right on the beach. And because we were doing this so much, we've found other people who are interested in doing this. And so our contractor for the project in Nigeria is actually Ghanaian. And we were working with him here in Ghana, and we had to export him to Nigeria to help with this project. Because funnily enough, even though Nigeria is just next door to us, or effectively next door to us, people aren't using rammed earth in Nigeria. So we brought that expertise. And, we're also interested in things like knowledge transfer so that people can then see how to actually build in these traditional ways so that other people can start to do similar things if they want to. So it's a similar way of how you would work with contractors in London or in the US. You find the people who are the experts and you start to have a relationship with them. And then when the project comes along, it was interesting. When the project comes along, then we know who that we should nominate as a subcontractor because we know that they can do the work.
So before we start talking about MOWAA, what are the drawbacks of this type of construction? Like, what would stand in your way of making this choice?
Um, I think it's just people's understanding of the material and what it can do and its longevity. It's all of these questions that are asked about washing away, about, well, what happened? Yeah, what happens when it rains? How long will it last? Does the water come through? And it's that understanding. And um, so okay, so I sort of mentioned pure rammed earth versus stabilized rammed earth. One of the other things that we try and do is, I've already sort of said, the rammed earth has its aesthetic aspects to it, but also, and it's got some performance aspects for insulation and waterproofing, but also the rammed earth on MOWAA is load bearing. So it's doing a lot of things at once. And so some of the drawbacks are people don't understand the construction sequence and how rammed earth actually behaves, because you can imagine in many codes rammed earth doesn't exist, right? And so your engineer has to understand how it actually works to be able to calculate safely, how you transfer loads from your roof down to the foundations.
So let's talk about MOA.
Should be
Um, let's start with a little background. Like, what is the history behind this project becoming a reality? What was the goal or the need that the client had?
okay. So this I've actually heard the stories from the client. He's told me on site. Our client Philip Ihinacho has had known our principal Sir David for a number of years, and um, Philip was interested in doing um, basically a storage facility for a museum. He wasn't. He was trying to facilitate the building of a museum, and so the initial idea was that it was going to be just a storage facility. But of course, he said this to David, who said, "No, no, let me do a sketch for you. Let me let me show you what it could be." And that was how the project was born. And so that's what's developed into what we have now, and it's much more aspirational. So the MOA Institute has a small exhibition component to it, but the idea is that it's a research and conservation hub for for artworks, for archaeological works. So most of it is actually about, yeah, artworks and archaeological works, conservation and storage. And the exhibition part is to allow people a glimpse into what is actually happening within the institute. So yeah, it's a small portion of exhibition, mainly about storage and conservation.
So, what did the planning process? I mean, I could probably ask you questions literally for days. What did the planning process look like on this project?
Okay, so yeah, uh, I'm always trying to put this in context. So the planning process, I guess the way that I would describe it is that um, in Ghana and Nigeria, the planning process is much more geared towards what it's like in the UK. Now, the UK is actually going through a lot of changes in the building regulations because of recent fires and whatnot. But traditionally and historically, the approach has been that the onus is on the design team to demonstrate how the building performs, as opposed to meeting specific codes. And there's quite a difference in that, right? The design team then presents to building control, and says this is how it works. Or you have the structural engineer also in the meeting saying this is how, here are our calculations and this is what we've assumed for structure. There's a report that gets submitted. So that's really what happens. And so in this project, it was the same thing, right? In the local, but I guess the thing is because this project was so special and different, there was already a relationship that existed between the client and the local government, right? So everybody understood this project and was willing to, have open conversations about it. So we still did have to submit, and everybody is still asking the questions about, oh, how are you dealing with car parking? How are you getting to the site? All of the usual things that people would normally talk about. But, it's just done in a slightly different way. And uh, because it was sort of backed by the local governor, I think many people were amenable to the project overall, but just making sure that we ticked all the boxes for the more more detailed parts.
Well, that's a perfect lead in for the next question, which is getting to the building department. I interviewed earlier on in the podcast, I interviewed an architect in Iraq who was, it was a home. It wasn't actually, a larger building. It was a home, but it was absolutely completely different than all of the other homes around it.
Mm.
And I got to the question about, okay, how does that go down with the building department when you're coming in with this, one of these things is not like the others.
Yeah.
And for him, he had a very challenging process in getting this home approved to
And
build it because it was different materials, different type of construction, this curvy
yeah.
building, and everything else is a square box, largely because of the history of the country, a war-torn country. They built things that were easy to rebuild.
Yeah.
So a bunch of, just square boxes everywhere. How does that look? Getting through that process with the building department with, I'm assuming, a project, the type of project they don't have a lot of background with.
Yeah. So I'll be honest on this particular project because we had an architect of record. Um, they dealt with the sort of face to face, but I know that from doing other projects like this in Ghana and in Accra, that the situation is similar. And what we try and do is demonstrate that it is not so different, yeah, from from other things that they understand, right? So when we're so we base it so from a thermal performance point of view, um, in say the East African building codes, there are definitions for of U values for compressed earth bricks, and so in order to have, supply the calculations to the building department, we did our estimate based on of the U values based on compressed earth bricks because that's a standard that people can relate to. And then structurally, it's a similar thing, right? The discussions with our Rand Earth consultant, who actually is a structural engineer as well, we basically agreed a compressive strength, a minimum compressive strength that then goes into their structural model that they can justify. And we did very early on a mock up and did test cubes and had the cubes crushed. So we've got then the evidence for that to say that okay, this is how it's gone into the structural model. Here's the evidence that the round earth can achieve that strength, and we'll proceed on that basis.
Well, there's a good way to get through the process. Here, we'll just show you. How's that?
Yes.
But I'm going to go off track again for a minute, but this has occurred to me twice now, so I just need to ask the question. So I now work for a building enclosure consultant.
Oh,
So I've done through the course of my career 4 different disciplines, which I think gives me a unique lens. But you had
mm,
mentioned earlier, talking about all the different layers in the building
yeah.
that in a traditional building, and how you have one in a
Yes.
rammed earth project. You have uh, so it's kind of a 2 layered question. Number one, I would assume that is a lot less expensive uh,
Yes.
to build, and what does it look like in the way of thermal performance?
Oh, yes.
Air and water and heat.
So we are just commissioning the building to find all of those things out for sure. But there was a okay, as I said, there was an assumption made on the performance of the envelope, and the the assumption was it's okay. All right, here we go with my units again. So in metric, it's 0.5 watts per square meter Kelvin, and in I guess American, it's zero point zero 0.09 BTU. Okay, so that is how it sits. It's not great, but the thing is the building codes. There's the the building codes in the UK and the US are quite elemental. right? You've got a sort of minimum for um, walls and roofs and floors, right? But I think the thing is construction is catching up in West Africa. So, double glazing versus single glazing. Many things are single glazed here when they should be double glazed. So, so what we've done is we've used a bit of a mix, right? So the wall doesn't perform, the assumed performance is a bit lower than what you'd have in the West, but we have that 450 mil thickness also to deal with. Um, and the windows are double glazed. The roof is insulated because that's actually the our biggest surface where we're trying to deal with sunlight. So we're trying to deal with it where we can or where we should, and also it's part of the design of the building as well. The spaces that are most sensitive, the labs and the conservation spaces in the building, are not against the outer wall. There's sort of a buffer of offices and other spaces around them, so that those are protected, in sort of layer of other spaces before you get to that.
Interesting. So we're finally getting around to MOA, which is why we're here. I mean, I had to get some background on rammed earth in there first because
Yes.
so many people are unfamiliar. So give me an overall description, just a broad description of what this MOA Institute includes.
So the plan of the Mo Institute is generally rectangular. And I'm going to have to use my metric units because my brain isn't quick enough to translate. So, and it's about 57 meters wide by 92 meters long. So it's rectangular, and the short dimension, so at one end, say our southern end is where the entrance is, and there's a slice of it, say 10 meters wide in that end, which is the exhibition space. So you enter from one end and you come into an exhibition space. And that's where the public can access. And the big thing within the space is that, as I mentioned, because this is about storage of artifacts and artworks, from that exhibition space where you can see what's actually on, you actually have a view into what we call the open store. And so when people are actually working on some of the artworks or any of the artifacts, what we wanted to do is to allow visitors to have a glimpse into the workings of this, because this isn't a true museum, right? This is the engine room of the museum. So the idea is to give people a glimpse of what actually happens behind the scenes. So that's the big thing. Our exhibition space and the open store are, for me, the two big the big items. But then we also have a small auditorium that seats 100 people that you can access so that the presentations can be given. People come in from the outside to do that. And then, as I mentioned, going around the long edges of the building, we have a series of offices um, around the outside. So natural light comes in from either side. And then the back of the plan is where we have all the conservation rooms, labs, um, all of the very secure storage rooms. They're all sort of in the center of the plan, so that as I mentioned, in terms of almost thermal, even from a secure standpoint, they're protected by layers of security. All of the technical rooms are at the back, generator rooms, electrical rooms, any of the mechanical rooms, and there's a loading bay. There's an open loading bay at the back of the building, and all of the sort of staff entrance is at the back, and any vehicles will come in through the back. Now, so I said it's roughly rectangular, but if you were to look at the plan, you probably wouldn't recognize that. So the um, the facades are gently inflected. They have concave curves along along the long sides. And that partially comes from this originally being a rainforest and wanting to be able to get trees closer to the building to help shade it. And of course, if you're drawing a straight line, between the edge of roots and the building, you'd have to stay quite a ways away. But the inflections are sort of helping receive the trees within the plan. And we also have skylights above the open store and in the exhibition space. All of that light can be controlled. And then we have long skylights over the office spaces as well and some of the conservation rooms.
So let's talk about the exterior in a little more detail now. Looking at the pictures, I probably would not, if I just glanced past a picture, not knowing anything about it, I probably would not have realized this was a rammed earth project right out of the gate. Tell me in more detail about some of the materials you used on the exterior of the building.
Okay. So, as a practice, we try and use a fairly limited palette of materials, and and then use them in different ways throughout the building. So what you really see on the facades is mainly the rammed earth, the very red rammed earth, which comes from the laterite in the local soil. I mean, if you were to look at any of the aerial views of the site during construction, the earth is actually very red. So it actually does reflect exactly what's going on the site. And then the the concrete frame. So, and I think the difference here is that the concrete color is not the usual gray that you would see. So, what we did here, which is also, I know we're talking about Rand Earth, but this is another story in itself, is that we actually used the local laterite to replace the fine aggregate in the concrete, which also which gives us a really warm sort of beige turning to red color for the concrete itself. I'm really pleased with how the concrete turned out. So what you're seeing is you're seeing a concrete upstand at the top, which actually sits directly onto the rammed earth. The slab, of course, could only be cast once the rammed earth walls were up because it's actually sitting on top. The so the rammed earth areas are framed because it sits on a concrete kicker as well. And once again, this is when I was talking about the formwork. You need the kicker at the base because you need something to attach the form to for them to be able to ram to start. So you have your concrete kicker and you have your upstand at the top. We've to deal with turning these sharp corners that we have. We've done fairly expressed concrete columns where the curved walls come together. And then when we have openings, very, very simply, when we have openings, we have they're glazed openings with bronze frames. So that they're all the same color. Now, we have large openings, um, most of which sort of arch openings that are large, so that you can really see how the rammed earth is sort of working in the wall because that's the arch that holds it up instead of it being a portal. And then the majority of the elevations have just very small, well, very small. They have circular openings, 4 feet diameter, so 1.2 meters, and they actually do bring quite a bit of light in. And those all have the bronze frames. Now, because I'm sure your listeners are going to be asking how how these aluminium frames actually work within it. The openings are actually framed in steel. So when it was rammed, all of the frames had to be in place. So that was another sort of construction sequencing issue that everyone had to be aware of, is that you couldn't finish the wall until you actually had the frames on site because they had to be rammed in place to take them to the top. So we had some very stiff steel frames, and those were sized so then the aluminum could fit in afterwards, and then those sealed with silicon.
Well, and that's was the point of that question is I'm trying to picture. I also did a stint in construction, trying to picture how this building's coming together. So tell me about the roof. How does how do you install a roof and are you using traditional roofing materials or did you have to do something special to make a roof work on a building of this type?
Okay, so the roof is all in situ concrete, all cast in place concrete. And there are quite a few columns within the space. So the rammed earth is really just picking up the edges of the roof and the upstone. But I guess the thing is we have all of the skylights on the roof, and I think it's that amount of openings that maybe were a bit challenging, and the sequencing. So the and and of course, because we have a limited amount of materials, some of the soffits of the skylights are all fair faced. They're all exposed concrete. So we were really paying attention to the contractor's formwork, layouts, etc., and his sequencing to make sure that we took care of any, say, issues with the concrete casting in the early stages. So we did things like, I'm sure you can imagine this. We did things like I insisted on casting from the back to the front, because the back areas, the technical spaces, people wouldn't be in. So if there were any issues with the concrete finishes in those areas, we could work them out, understand what the problem was with the mix or their placement. And so by the time they got to the front, we wouldn't have any of those issues. And so did that with the skylights as well. Wanted to start at the back and move forward. But, everything doesn't always work according to plan. And I think there was also a jump in scale from the skylights at the back to the ones above the open store, where I think the contractor had some challenges. But yeah, if we haven't sent you all the photos, I'm sure we will. And they've come out really well. So the roof itself then it's a green roof. Okay, for the most part, it's still a conventional roofing system, the inverted roof, so that we've got the roofing membrane directly on top of. Okay, we have a screed to falls to get our slopes, to get our drainage. Um, on top of that, we've got a membrane adhered to the screed. And on top of that, we've got our filter layers, insulation, and then concrete pavers where we've got walkways or gravel when we've got edges, but we've got a green roof for most of it. So you've got soil in a lot of it. And what's really interesting about being in Africa, I say green roof, it's actually a brown roof. So we didn't seed it. It's just the soil. But what's really, really interesting is that, it's meant to pick up any of the local flora, right? Any of the seeds that are local to it. It's already green, right? Because the things grow so quickly and the rains are so heavy that our roof is virtually green already, where the green roof exists.
Without even seeding it.
Yeah, without even seeding it. And there's quite a bit of the MEP is on the roof. So because this is a one-story building, so we don't have, we only have basements at the back having to do with water treatment and our rainwater attenuation. So most of the services are through the ceilings. So in the front of house spaces, we do actually have a ceiling void. So and the usual practice here is to expose the units, the HVAC units on the roofs, and come through the roof and distribute in the ceiling that way. So we're not coming up from a plant room and then trying to distribute. We're actually on the roof coming down for most of that.
I think one of my favorite questions to ask is about challenges, because I think we learn the most from in anything in life, in the challenges that we face. The easy stuff is easy. You don't,
Yeah.
you don't learn a lot from that. What did you find specific to design? What did you find the most challenging to design on this building, and how did you make it work? What stretched your skills on this one?
Well, okay. So I think in terms of the design, it's the I think the issues really had to do with trying to anticipate what the collection was going to be on this project, right? Because we're not sure what we're actually going to get. So it was looking at the criteria for keeping the building at certain humidity levels and the security levels as well, within what we're doing. Because from a design standpoint, I think the building is very straightforward. So it really came to everyone understanding that we're not covering up the concrete, right? I think that a lot of times, especially here in West Africa, the assumption is that the concrete will be covered up so that the contractors are not paying as much attention. And then you have to find some way of dealing with the fact that the concrete is not good enough to be exposed. And you have to find ways to rectify it. But luckily, we communicated all of that information pretty clearly to the contractor. So he was set up for the fair face concrete portion, but what he wasn't set up for was things like the colored concrete. So that's the bigger challenge probably. And I guess when you're coming from different places and you're assuming that people work in a certain way, you're always trying to find a way in. So we, for a while we were asking, who is your concrete technician? We want to talk to the guy who's in charge of concrete on the site. But the way it was sort of working is that the contractor and the guy who was supervising it was also in charge of the concrete. So, so he was doing a lot. And in the end he got there. But I think if we understood that, we probably would have done it differently to start with. We probably would have insisted on being there with him and saying, this is how you go about it, as opposed to being more sort of trial and error, because it costs a bit of time. But the colored concrete, I think, was probably the one, but it's also the thing that I'm probably happiest with, because the rammed earth is a little different, because we always knew we knew that the rammed earth is going to be a challenge, which is why we sort of took it out of the hands of the contractor and gave it to somebody that we know who could do it. But then that was a different challenge. The challenge is how to get the contractor to work with your nominated subcontractor, where they're not used to working in that way. And so yes, there were a few things. And then even just in terms of mock-ups and testing of things, it was making sure that we did test them, so that we're happy with the finish that we're getting, and then making sure that we can then repeat that within the building. I think the contractor himself, the main contractor on site, understood all of it, but some of his guys didn't. So he had to be there. And you can tell that the times when he wasn't on site, that's when things would go slightly wrong. So, there are a number of things which, not aren't fully about design, because I think we, understood how we understood what we were getting, so that's, we knew what to pay attention to. But it's actually the smaller things that yeah, I know what I would do differently. Absolutely.
Well, but that in itself is such a lesson. I mean, anything you do the first time, nobody does it perfectly the first time.
Yeah.
You learn some lessons, and think I can only imagine how much the different contractors involved learned in this process, and maybe looked at, if they're not used to, the main contractor and the subcontractor working together in certain
Yeah.
ways, how they might look at that differently going forward as a
Yeah.
benefit to the project.
Yeah. I
I
think
love those
that
lessons.
the one thing that I'll say is that I think that the contractor assumed, because you can imagine, if you've seen, you work for a building envelope contractor, right? You know what a facade drawing looks like. There's lots of lines. So you can imagine when the contractor first looked at our sections through the wall, he didn't think our drawings were finished,
So,
right?
what do I do with that?
Yeah, I think yeah, he's like, these drawings are only concept level. It's like no, 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 no. So you know, when once he understood, it became very different.
So, I just as an aside, I'm kind of curious. Is a rammed earth building as structurally sound, and will it last as long as is a typical
Ab-
building?
Absolutely. I mean,
Nice.
it's interesting, you know, when we look at the history of random buildings, when they don't even have they didn't have the technology that we have. These buildings have lasted for thousands of years, actually. So we are similarly confident that um, the longevity of these walls will be the same, and same as its structural frame, at least, which we designed for at least 100 years.
Let's be before we get into more details about the interior spaces, let's talk about exterior aesthetics
Hmm.
for a moment. What choices did you have with this type of construction on this project in like textures or did you really rely on the earth to kind of send the message on its own?
Yeah, for this one, yes, the earth and the earth colored concrete. It was really that's what this building is about because I sort of keep saying it, but it's really true. This is not the museum itself. This is not
Right.
the gallery, right? There's part of the point of this building is it is the sort of workhouse. This project is part of actually a larger campus, a larger sort of arts campus, and there are future buildings that are planned. One of which is an art gallery. Um, there's some refurbished colonial buildings that are going to be on the site. There's a hotel that's going to be on the site. So this one has its own aesthetic. And so even to the point where, the fair-faced concrete works well, we didn't think that we needed to texture it because it's, first of all, because it's good enough, but it was always the idea that it was fair-faced. And, because it was fair-faced and the contractor, did understand in the end that it was going to be exposed, you know, the concrete is actually pretty good. And if you look at his tie rod holes, everything lines up, and we're expressing the construction in it. That's actually the beauty, as opposed to choosing something to put on top of it. In the photos, you'll see that when you're looking at the elevations, you can see the slab thickness of the roof, and then he's cast the upstand on top of it, and we didn't fill those joints, right? To say that it's one. It's like, no, let's celebrate the construction, and because it was all done neatly and well, we have no problem expressing all of those things. So it's letting the materials and the construction speak for themselves. That's the beauty of this. I'll also so okay, when you're asking about the choices, when we did the first mock-up for the rammed earth walls, and of course they came out very red, and the question from everyone was, is it the right color?
Do you have a choice?
Oh, but this is the thing, but the point is because it's reflecting the earth, we're happy with that color. Right? There's a range in there, and as long as it is reflecting that, we can take it. So it's not like, I guess that's the difference. We're not after a specific color, and that's what it has to be. But part of it is, let's find out what the right color for the building is. Because
Yeah.
that was the thing with the concrete as well. When we tested and we got to a certain point, we just said, okay, we think this is probably the best that we're going to get in terms of color and workability. So, with both of those things in mind, this is where we stop.
But for a project like this, I number one, I'm a minimalist, so I love that you didn't decorate the hell out of everything. But a project like this, being a rammed earth project, I think it needs to speak to what the earth is saying, not to what you are choosing for it. I think that's what the only thing that's really going to work the way that you want it to,
Yeah,
the message you want it to send.
yeah. Can
Uh,
I say one other thing about the
sure,
render before I go to the
absolutely.
inside, just so that people understand about this? Um, the other thing is that the render is really forgiving. It's really forgiving because there because you can construct it so quickly. There were times when the walls were built and they didn't fill the tie holes right away, and then they were patched later, and you could see the patches. And you're having a conversation with the contractor about, okay, how can you deal with this? And he said, it's more hassle to fill it or to fix it than it is to take the wall down and rebuild it. So that's what he did, because the materials. Because if you think about the materials, right, we still are talking about there's a bit of cement, but the sand and the laterite that we used, you know, it's not like that completely blows your budget or anything.
So did they just take the wall down and use the same materials and just
I
get
think
those
because it was
parts
new enough,
right?
they could actually reuse some of the materials. Yeah.
Wow.
If it's too old, then they can't, because then the cement goes off. But if it's fresh enough, then they can. So, and the other thing is even the repairs, they can take off, say, the outer sort of, okay, here we go, what, half inch depth, a centimeter, 1.5 centimeters, and they can re-ram, right? They can re-ram it and give you a new finish, because that that outer centimeter is not affecting your structural integrity of the wall.
How often do you
It's a,
get to
it's
do
a
things like that on a building?
yeah, it's a great material.
So let's go inside for a minute and talk a little bit in more detail about the interior spaces and what's unique. But before we do that, I have to ask, because this is I know it's going to sound stupid, but it's the first thing that popped in my head as I was looking at this project on the inside, and I understand it's the workhorse for the museum, but there is an exhibition space. I'm like, okay, I got to know, how do you hang something on a wall
Ah,
in a
yes.
building like this? Like, how does that work?
Okay, so you're right. The idea is that we don't want to hang things on the walls. The round earth walls are stay pristine. So what we talked about when it comes to the exhibition design is, because these are smaller works of art, and we're thinking about artifacts. We're looking at display cases, vitrines, so that there are more objects in the space. Is really how that was considered. Um, but so we weren't the actual exhibition designers on the project, so we worked with another consultant in Germany. And so as the ideas of the space developed, then we started to understand there were going to be permanent exhibition parts, which would then be sort of floor mounted, and then there was a temporary exhibition space. And to increase the flexibility of that space, we actually even included tracks so that you can hang things from the ceiling within that space, right? And those tracks were sort of engineered separately, and they can take actually quite a bit of weight, so that if you've got something very large that you want to support, you can, by using all three tracks. But yeah, we've accounted for that within the ceiling, but it was also floor mounted is what we're looking at.
So tell me about Maybe highlight a few unique spaces inside the building, or unique things you did in your interior or interior aesthetics. What's special that you'd like to talk about on the interior?
So, I mean, we've got very few materials. It's very simple. What I have to admit, the space that the open storage space is actually one of my favorite spaces. And that's also because there's nothing in it yet. And just that when the sun actually comes through the skylight, it really shows off the building. And that will still be apparent when things are in it. But then we also have a sort of, it's not quite a black box, but the auditorium space. I actually haven't talked about that. The only other material that we have is that we've lined that in timber. And so timber floor, timber battens on the walls, and timber ceiling. It's for acoustics, and so that it's got a very different feel than the rest of the building. And the beauty, yeah, the beauty of that timber is we talked about sustainability a lot there, and so we're using timber from Lake Volta here in Ghana. Now that timber is actually sustainable because Lake Volta is a man-made lake. It's the largest man-made lake in the world, and so it's Volta because it was dammed. The valley was dammed to generate electricity.
Oh,
All right.
creative.
But of course, it's such a huge area that the trees weren't cut down before the dam was erected and it was flooded. So there are actually trees in the lake, and the trees are actually a hazard for people who want to use the lake, who want to fish in the lake and whatnot, because you can't actually see how far above or how far below the surface that they are. So they're slowly taking those out. But it turns out that that's a great source of sustainable timber.
From in the water,
Yes.
and it's not
So
damp. Okay, I'm trying. My brain will not wrap around getting timber out of the water. Please
so
explain.
So it's really, really interesting. So I think when they first started this concession, we did a whole study on this when we wanted to use it so that we could see what were their issues. And it turns out there was a study that was done years ago that compared timber from Lake Volta to fresh timber to see what the moisture content was. Now, it turns out that the trees don't continue to absorb water, right? There's a maximum, and it turns out that that maximum is virtually the same as when the trees are alive. So they're not, they don't have more water in them when you take them out. And the difference is though, when they're in the lake and they're in the water, what gets washed out is the sap. And the sap is what gives you the weaknesses when it's drying. So it turns out that this timber that's been sat in the lake for decades is actually stronger than trees that you would cut down.
That's interesting. We do an annual in my family an annual Mother's Day trip to a place here in Oregon called Clear Lake, and we get cabins around the lake. And I go with my kids and my daughter-in-law's family, and there's a whole group of us. And they call it Clear Lake because you can see
Yeah.
way down in this lake. But there is I always call it a petrified forest,
Mm.
because where that lake is, before a volcano exploded, there was a volcano there, and it exploded and made this depression, and the lake was formed.
Right.
And there's all these trees that you can still see under there that have been there for, this is way longer than decades. I don't know, hundreds, thousands. I don't, they're big, huge stumps these days. But I always was fascinated with these trees in the water that have been there for some crazy amount of time, and you can still see those tree trunks.
Yeah.
And I thought, how do they not just erode and rot away in that many hundreds or thousands of years that they've been under there? So now I've just learned My mind is blown right now mining trees out of a lake.
But
I
that's a
have
different
truly never
podcast.
heard that. Yeah, that is a whole different podcast. Um, so, what are the environmental benefits of RAM? You've touched on a little here and a little there, and there's one question I actually missed. I want to go back to in a minute. But what are the biggest environmental benefits of doing this type of construction?
Okay, so it's the reduced carbon content, right? And if you were to well, I don't have sort of numbers of comparing directly to concrete, but concrete is one of the worst offenders. So we're trying to reduce our use of concrete, and so that's really one of our goals of using the round earth. And I guess, yeah, so that's for me, that's the biggest benefit for it. But I guess what we can also talk about is that we've also in combination with the round earth, there are other sustainable features within the building, maybe that we can
Yeah,
so maybe
absolutely.
kind of round those out. So what I didn't mention is that on all of the skylights, we actually have louvers, fixed louvers that block out direct sunlight. So you get indirect light, but we don't get the direct sunlight. So of course that helps with your MEP loads within the building, right? And the green roof, that green roof, sorry, our brown roof thickness, along with the insulation that we have, and we're actually collecting the rainwater from the roof. So rainwater attenuation, and we want to use the water for irrigation for the landscape because we are replanting the garden around the building, so that so that the staff and visitors can use the garden around the building. Oh, and of course, some of the usual things that we don't talk about much, lighting control, save energy within the building. We've got different settings so that we're not expending so much energy. And even some very simple things. We've got roof overhangs where we've got our large windows. It's actually when we did the modeling, um, yeah, so a lot of things that we do are sort of integral in the design. It's not so obvious. So that's why I'm putting it out in this way. But the arched windows are then under overhangs, and so when you so the windows are shaded in the first instance, but of course in this part of the world the sun's very high, uh, not just at noon, right? So in winter, it's there's a slight angle, but the only place where the sun will come in is that first thing in the morning, last thing in the evening. But because of the overhangs and the arch of the windows, that's all minimized. So even though we have high performance glazing, also to keep the sun out, we don't get that much direct sunlight. So it's all sort of integral within the design.
And likely very important because, as you told me before we started recording, it gets pretty hot there all the
Yes.
time
Yeah.
because it's hot today.
Yes. So that's right. And so we're trying to, keep from having to fight all of it when the sun is actually in the building. So the louvers, the overhangs, the double glazing, the the insulation on the roof, all of these things. Oh, and I forgot to mention, we also have photovoltaics on the roof. So on top of all the skylights, we've got photovoltaics, and we've tried to max those out. We always had those on, but the client has been actually really good in helping us want to max that out. So we have a carport that has PVs on it, so that we can generate as much of our own electricity as we possibly can. Because the other thing about being in West Africa is that sometimes the grid isn't as reliable as it is in other places. So being able to use solar power to generate our own electricity is a huge benefit, because then you don't have to run the generators when the mains power is out.
So I want to back up for just a second. I was going to skip the question about services because you talked about that a little bit, running things up,
Mhm.
through the roof. But I want to revisit that for a minute. When I was doing some of my research for this interview,
Isn't
um, that was one of the first things I thought about because so often we run all kinds of things in the walls, wiring and whatever. And one rammed earth project I saw had it said they actually put their piping inside the walls.
uh, mm.
And I was thinking, well, that's kind of crazy. What do you do when you have to fix a pipe? So did you run everything through the ceiling? What
So
heating, electrical, air conditioning, where is all
yeah,
of that?
yeah, all of that
Plumbing?
is okay. Okay, so the all of the big things, yes, are in the ceilings. And when we get to the places like the big store in the middle, we do actually run some of those services on the concrete. So it's just very small conduits, but we tried to coordinate well with the engineers so that it's only the conduits. No, it's never air. So we've got quite big nozzles on either end of the open stores that are cast into the concrete. So they've got the units behind, the fans behind, blowing into the space. So yeah, we tried to design around it. I mean, it was only that one space that where the concrete was exposed, where we didn't have a ceiling to run anything. But electrical is in the floor, so we do have a floor screed. So we had a floor screed depth um, where we were able to run conduits, and we have floor boxes in many places. So yeah, in the exhibition space, we have floor boxes, so you can access the power that way. That's in the offices. There's grids of floor boxes in many of those spaces. So yeah, floor boxes. So that's electricity and low voltage, right? Electricity and data.
What about
Um,
plumbing?
Plumbing? Oh, okay. So plumbing, so we have toilets in various places. All of that runs under just our ground floor slab.
Okay.
And we and so okay, but we do have rainwater pipes that we can go off. So we incorporated the rainwater pipes within blockwork walls, not concrete walls or rammed earth walls. We brought everything in from the sides. So we were always conscious of which walls we wanted to avoid when we brought stuff down.
Interesting. Yeah, I was looking at the pictures and I'm like, I have to know where where
Yeah,
is all this stuff because I don't see it, which
yeah.
makes me
I
happy. Nobody ever wants to see it, but
yeah. I forget we because we were that was always a goal, but and even forgetting because it's fairly effective.
so I always like to talk about construction for a little bit because I'm sorry, there's always a good story. Every project, I don't care what project I talk about, there's some good story during construction. And I have a hard time picturing what the construction phase of a project like this would look like when there's a big learning curve. It's a material that maybe people don't use all
Mm.
the time. Um, and then coordinating that, you're in Ghana, projects in Nigeria. Like, did you have to like live in Nigeria for a while? What did the construction process how did it go?
Okay.
Tell me a good story.
Okay. So what it looked like is, as we said, we had a local architect, MOE Plus, who were involved, and so they're based in Lagos in Nigeria. So they're closer to Benin City, where the project is, than we are. But having said that, we the what was instituted at the beginning of the project when the contractor was on site were fortnightly or biweekly site meetings. So all of the consultants would go to the site, meet with the contractor every 2 weeks, And that was sort of a check-in. Okay, any issues that are coming up, and we'll deal with those face to face. Um, Even though, of course, as we talked before we started, many things we can do remotely, but construction is one of those things you need to see the whites of their eyes, and vice versa. Yeah, so that's what we did. But it was interesting. There was a lot of course, there was a lot of conversation back and forth, not um, uh, that was not face to face, and um, but that's really how it was set. It was structured in that way. I think the other thing that we had, on a Monday, we had an internal sort of project meeting to sort of set the week. What are the issues, and then we had that contractors meeting. Sometimes we tried to have, well, of course, we had ad hoc meetings with various specialists as they came on board. Like the facade guys, so that they can understand how to do the. Yeah, you know what? It's really funny. I'm skipping over things, but so you can understand, the facade guys might be interested in how they're doing their nice facade in a curved wall, and how we define the geometry for some of those things. So yeah, we had to go through a lot of those. And yeah, it was just it was intense, and the issue was, yes, there was a learning curve on many things, because we also didn't know how much the contractor knew, and how much his subcontractors knew, or how much they would do, and who we would get shop drawings from and who we wouldn't get shop drawings from. There was a lot, and then sometimes, like with the roofing, um, we redrew everything to make sure that it was 100% clear, because we knew we weren't going to get drawings back. Right? We had to define everything. So some things didn't go the way they normally would, but other things they were more used to dealing with, or the subcontractors were more used to dealing with. Things like the windows were actually relatively straightforward, but it was just them understanding the geometry and saying, this is what we'll accept. This is we can deal with this as a facet versus this needs to be curved. Just things like that.
So those regular see the whites of their eyes meetings were really, really critical.
Absolutely, absolutely, yeah. I, they always need to happen. I think.
Well, I think every project should be like that, because I do think it's a game changer. Just having the conversation. Don't write 30 emails. Just sit down and talk
Yeah,
for
yeah.
it. I think it's better just for the relationships of the people on this side as well. Written word doesn't always come across the way you hope it does. Uh,
Well, and you asked the question about being an international architect. It's like, look, a drawing does say a lot of things that an email doesn't, but there is still the interpretation, right? Even just between the U.S. and the U.K., the amount of terms that are different architecturally that you wouldn't think are an issue, right? Things really simply, like vertical vertical and horizontal mullions, right? Whereas in the UK, it's very clear, a mullion goes up and down, and a transom goes across. So it's things like that you don't know where people are coming from. Which system have they been working in, and so you have to sort of tease it out. And it's for me, it's this thing of always sort of saying, okay, this is how I would do it. Please, you tell me how you would do it, so that we can kind of get there. Because what I always say is that, look, we're not the construction experts. Yeah, architects, we design things, and we do know how to. A lot of us know how to build things, but that doesn't make us necessarily the experts, right? Somebody who's just doing building day in, day out. There are some other ways that they may know how to do things that we don't. So those are also valid. As long as it doesn't jeopardize your overall sort of design intent, that's fine.
I always say I do a fair amount of teaching, and I always tell my students as they're starting out in their careers in architecture, I tell them one of the most valuable things you can do is get outside your box.
Mm.
You may be coming out of architecture school, but one of the most valuable things I've done is work in multiple disciplines. So I look at everything differently than a lot of my colleagues who have only worked in one discipline. Would you say that they working in all these different countries that you've worked in and having to, because every country is different, every understanding is different, codes are different. Would you say that that has been a game changer in your career of being able to walk into this new place with people that do things differently and be able to navigate that path?
Yeah, yeah, it is, because I think, we can get sort of caught up in doing things always in a specific way, right? And when, and in what we do and working internationally, people do it differently, and that doesn't, you know, it doesn't make it invalid, right? It's still valid. And so, you're looking at what the benefits are, right? And the benefits usually, well, the benefits are usually related to the context that they're working. Everybody understands that context. Everybody's used to doing it in a particular way. And so you couldn't introduce something new to it to try and change their system. So you have to be flexible with it. I mean, the thing is that one of the thing that is consistent is actually construction. That process of casting concrete, it's still the same everywhere you go. Some people have better or worse formwork, but the process is still the same. And I guess the thing that I didn't say at the beginning is I was also lucky that I actually started the wrong way around. I didn't start design wise. I actually started out when I said I'd worked in a local firm, I was actually on site, um, as a sort of field, as an assistant to the field reps in the practice that I worked in. So I learned construction and design. So before I ever was in architecture school, I was on site. So knowing what it looked like has helped me because I always know what it's meant to be and what it should be. I've just tried not to let it stop the design process.
It's funny you say that because I've always said that I think that a some kind of internship in construction should be required in architecture school. I don't think you could have
Yeah,
started off on any better foot to have
yeah.
that, be on site and have that working knowledge of how all that goes down before you start designing. I think the
Always
best designers are the ones that have actually worked in construction at some level as well. So, what was your biggest lesson learned from this project that's going to make you an even better architect on the next one?
You know, look, I don't think there's one particular one. I think it's really about um, you know, under, it's really more about understanding the context that you're working in. Because even the relationships between the client and other consultants and the consultant and the contractor, when they are sort of working in a smaller context and have already crossed paths before, it's really that was actually really interesting. And and I guess just being aware that we are looked at as the international architects, and so the leadership that architects normally have is the there was probably even more weight on us to help this process through, and just being aware of that. I think I've said it before on this call, but things that are obvious for it or should be obvious, a lot of times aren't. And I think it's just making sure that you don't sort of just skip over some of these things.
Because you just assume that everybody has the
Well,
same mindset or thought process
yeah,
or
mindset, thought process, idea of what the roles are, everything, right? It's like just Yeah, it's yes, okay. If I were to boil it down into one thing, it's let's be explicit. Let's be more explicit about things.
Good advice. So before we get to our two closing questions, tell me what you're working on now that you'll be getting a phone call about me in the future to come back and talk to me about.
Um, so okay, uh, okay. So there's a couple of projects that I might mention. One one of which is going to be unveiled at the Venice Biennale,
Mhm.
and
Oh,
yeah, in the very near future. A project here in Ghana that has been in the office for ages that we're really proud of. And there's a anyway, it's the what do we call it? The Cancer International Children's Cancer Research Center. And the idea is to have a state-of-the-art sort of children's cancer hospital here on the African continent.
wow, that's pretty impressive. Assuming there isn't one right now?
That's correct.
Oh, wow. Well, I mean, okay, so I know where to find you now, so don't think you can hide.
So yeah, as I said, that's going to be unveiled at the Biennale in a few weeks' time. So yeah, that's a really important project. I think I guess the interesting thing for our practice is we are say known for our cultural projects, museums, etc. But we also like to do some of these others that are also important, and we'd like to think that we can bring something special to these other building types as well.
So I always close with two questions. One's a little bit broader industry question, and the final question I make everybody answer whether you want to or not. So the broader industry question actually for you today isn't as broad as I would normally go because this is such a unique construction type. I decided to stay within the theme. Usually it's some random question about the practice of architecture, what are the biggest problems or that kind of thing. Um, literally could have asked you questions about this project today for hours. It was really challenging for me to come up with a list, and I want you to know I went through every single page of the 119 page rammed earth presentation that your office kindly sent me for reference. And it really the whole concept is mind-blowing in my opinion. If you could share, drop a little knowledge and share the top five things that you would like people to know about rammed earth construction and its benefits, what would you say to people?
Oh wow. Okay. I always have difficulty with top five sorts of things, but I guess we're working with a number of consultants and talking about these issues a lot, right? Because we're very, very interested in using around dirt. I think, and especially for listeners in the US, um, rammed earth is actually has more benefits than are actually obvious, right? Because most of the projects that we see are stabilized rammed earth, so they're sort of the rammed earth. So they are rammed earth, but because of the cement, they tend slightly closer to concrete. But the pure rammed earth actually has many benefits. So maybe if I can get five of them straight in my head, maybe
Just
that's
pick a few favorites. We don't need an exact list of 5. Just tell me about a few of your
yeah.
favorites.
But the roundup, because of the clay content, actually, first of all, acoustically, you get acoustic benefits within a space. The the clay in the rammed earth actually helps even out the humidity levels. It actually stabilizes the levels within space. It actually even has hypoallergenic properties. I know it's sounding like it's magic, but it's true. So I think that so I think when you find people who are really into round earth, this is why they are, is because there are all of these things that, if you were to build with it, you would never go back. Especially when many people use it for their houses. But it's and the thing is, yes, it's a historic material, but you can use it in a modern way, right? It is not going backwards. I think, as architects, we can get obsessed with products that you can specify, that you can say very clearly, I know it's this thick and it's this U value and it's going to do this for me. But, I think, when you think about all of those bits that you have to put together and the different places they have to come from and the carbon that it takes to deal with all of those things, when I say it's more sustainable, it's like we kind of need to break it down into, just think about, I mean, somebody should do a study on this. It's not me, but, take a couple of meters of wall and look at what's in it, an external wall, and do a carbon comparison, because putting it to concrete is easy, but it's not actually doing the same thing. But I think that it's just the potential of it. And if using it as your external surface is too too far to go, then maybe look at internal walls for just internally, maybe looking at round earth, or for pavilions or things like that. It's just, we people do not know it as a material. So I think that just getting to know it through experimentation would be one of the things that I'd like to pass on to people, because it's very different than I think people would think it is.
Well, hopefully, after this episode comes out, we'll have a few more educated people running around out there. So, final question, um, my favorite question in every episode. I hope that we all are trying, or we all hope to live a life that leaves some sort of contribution to make the world a better place. And so, personal or professional, big or small, because I truly believe that some of the small things have the biggest impact. What do you hope your impact will be?
Hmm. Um, well, actually, this one is actually two things. I would like to continue to work on buildings that actually matter to people, that people actually enjoy, and not just aesthetically, but because of their function and what it means to the communities is one thing. Because I think some of the projects that we're doing, you'd be surprised at the impact that they have. This MOWAA project, um, it's one thing talking to the clients, but I think people in Benin City see this as something very special for them. And the other thing is just training architects. You're doing it in terms of teaching. My thing is I do it to practice. Those are my things, right? Training up young architects. Um, there's I mean, you should come to Accra. You should have a look at our studio. There's probably no studio in the world that looks the way we do.
I would like sell a kid to be able to come to Accra and see your studio. Yeah, mentorship for me is, I would not be sitting where I'm sitting today in my very untraditional upbringing, so to speak, in this business,
Mm.
had it not been for the people that took me under their wing and taught me things along the way. Very much trained in the trenches in this business.
Yeah.
And I truly, to the core of my being, believe that I have a responsibility to give that back
Right.
to those coming behind me. And so I don't know that I have any larger amount of respect for anybody in our business than for the people that are not taking their knowledge with them, but are actually embracing the next generation that are going to do things we'll never even know what our impact will be on those young people as they move through their careers. Professionally, at least there is no higher calling for me. So I applaud you for that. And I could tell just by the way you your eyes flittered a little bit answering that question. I'm a student of human behavior, and it's like you can tell when somebody means what they say, and you can tell when somebody's saying the company line. And I could watch you feel that question as you answered it. So I applaud you for that, and thank you for sharing that with me. Ken, you can come back absolutely anytime you like and talk to me about one of your projects. It's been an absolute delight chatting with
Sweet.
you today.
Thanks very much.
And I'll let you know when I'm going to be in town. You
I'll
could show me the
I'll look
project
for
in
it.
your studio. Okay. Thank you again for joining me today.
Oh, it's been a pleasure. Thank you very much for inviting me.